my name is Jason Walker. I am a Microsoft Premier Field Engineer. We're going to be talking about multi-threading PowerShell, speed up your scripts. Anybody here attended Tomei's session? So some of this stuff might be redundant, hopefully not. This is presented in an approach on looking at the different methods you have to multi-thread, and whatever method you choose is up to you, whatever suits you best. So there's always a story behind why you do things you do, and one of my customers is the DoD, and they have close to 20 sites on the other side of the earth, and they have close to 100 Exchange servers. Anytime something's wrong, the question is, where else is it broke? And if I was to write a script that would hit each one of those servers sequentially, we'd be there all day, and they'd probably walk me off site. So, I went down this road. Hey, how do I multi-thread this? How do I make this faster? So, the options we're going to go over: remoting, PowerShell Jobs, Runspaces. We're going to look at for each parallel. It's a PowerShell v3 feature. Is anybody here running v3? How many people here have v2? How many people have v1? You're going to be asked to leave if you did. v4. Yeah. How about v4? v4. Awesome. All right. So remoting, multi-threading and remoting is built in. It's very simple. Invoke-command, computer name, you pass computer name, an array of servers, script block. What do you want to run on that server? And there's even a throttle limit parameter, so you can specify, how many threads you want to run concurrently. There's some caveats to that. It's not, it's not all roses, but we're gonna look at that. So, and invoke command isn't the only command that has it built in. So anytime you see a command that will accept an array for the computer name parameter, or and has a throttle limit parameter, such as get WMI object, hey, that has multi-threading built in. So, you guys see that all right? All right. So, this is a basic function. I had this code wrapped up in a function just for demo purposes. So, I have 8 servers here. We're going to look. We're gonna hit them all at once. We're gonna look for a 1074 event. Anybody know what a 1074 event is? That's who shut down the computer. Let's go ahead and run this. As you can see, it's going to run. It's going to return results pretty quickly. Let's see how fast this is. So I'm just going to run this through a function. This is going to see how long each iteration takes. I'm going to run it through 5 times. And it took just under a second on average. I'm going to copy these results in just so we have something to compare. All right. So, what was I talking about? So let's look at what I was talking about. That the results that come back are serialized. What do I mean by that? So when they're serialized, sometimes the nested objects aren't seen. So we just look at this, just by itself. It'll look like I ran just get one event, without being inside invoke command. Got this to format list and look at everything. We can see the property here. We can see, that it has this eventing reader event property, inside it. So let's look at that, see what's inside there. Just a bunch of strings, not very usable anywhere beyond that. And for those of you who don't know, what the property has are the replacement strings. So in an event, you have the canned message, and then you have variables, and then the replacement strings fill in the variables. And so I'm going to run get win event by itself so you can see what I'm talking about. See, so here are the replacement strings. If we look at the message, you can see where the fill in the blanks are. So Mellow 1 has reason code, user initiated, or NT authority. You guys get the gist. So why is that important? Well, it's important because when you want to write a script looking for something specific, like in this example, who shut down the server, right? So when we have the event that's not serialized, we can look at that property, we can go right after who shut it down. If we don't have that, we have to parse through the message and get the data out. So basic example of that is we just we'll run this code. So I have the object where I just have the machine name and then who shut it down. And so for me, the properties, it's important to have that around. Now, how do we get around the serialization? Well, on an old command inside the script block, if we get that variable out inside the script block, that way it's not serialized when we get it back. So let's go ahead and run this. So that makes a nice workaround. You can see the machine name and then who shut it down. All right. So that is using remoting. PowerShell Jobs. One of the good things about PowerShell Jobs is you don't have to have remoting enabled. It's a little more complicated. The output is still going to be serialized. And PowerShell Jobs is probably the slowest option we have. However, it may be the only option you have depending on your environment. So when I say it's more complicated because there's nothing built in to handle the throttling. So if you only want 10 to run at the same time, you're going to have to put in a code for that. You can't just do start job dash throttle limit 10. That's not there. You're going to have code to monitor those jobs when they're complete, and then you're going to have to call a receive job to get those results back. So again, run the exact same command against the exact same servers. Let's go ahead with this and run this. You can see the jobs that get kicked off. We have to wait for them to complete. You want better?
Yes.
Yeah, some of my stuff's going to get cut off for a little while. Just to show you that it is serialized. All right, so let's see how long this takes. And we can already see that it's already just seems longer than it did before in the remoting example. So the same amount of work, and it had an average of just under 3 seconds. We'll keep this just so we can compare at the end. So I wish I had a complete example of a script that uses jobs, but I don't. So let me do myself here. So That is jobs. So Runspaces. Has anybody heard of Runspaces? So Runspaces is probably the fastest, probably in every scenario. However, it takes some developer-ish type skills. It's complicated, you know, C-sharpish like code, and I'll show you that here. Throttling is built into Runspaces. Well, it kind of is. So when you create a Runspace pool, you can specify a minimum and a maximum amount of Runspaces that can run at one time. So if you kick off, say you have 100 servers and you only want to run 10 at one time, once that 10th one is done, it'll automatically start the next one. So that is nice. So here, the most basic example is say you do Runspaces. On this one screen. So first off, we're going to create the Runspace pool. Let's open it. We create a PowerShell object. Attach that Runspace pool to that PowerShell object. Put the command in it, run it, and then get the results back and do some cleanup. I guess I could run this and really, you know, all this is getting to do the same thing as if we just ran git process. So this is a more complete example. Again, this is doing the exact same thing we did in the, getting back the exact same data. So here we create a Runspace pool. We're going to spell, we want a minimum of 1 and a maximum of 10 Runspaces at the same time. Here's the command we're going to run. We have to pass that command to a Runspace and an argument, which argument would be the computers. We're going to create a collection of all our Runspaces. And then once they're all finished, we're going to look through them, and once they're done, we're going to get back to results. Let's go ahead and run this. And we can see back, we can already tell that's faster. It's almost instant. So let's see how much faster. And then, you see well under half a second, with the minimum even right there at a quarter of a second. This just for comparison. And here's a more complete example of Runspaces. To go back to my story, I needed to get the information the customer wanted was in the event logs. So this function accepts the filter hash table, just like get when event does, and I use PS bound parameters to pass that to get when event that's inside the Runspace. So pretty much whatever you specify in get filter hash table, it'll pass that on. And this script I can query 70 plus Exchange servers across on the desert, on the other side of the world, in about 30 seconds. So this is definitely a lifesaver for me. Do you guys have any questions so far? I'll keep trucking in. All right, so for each parallel, again, this is a PowerShell v3 command. The output is going to come back serialized as well. And again, to use this in this way right here, you're going to have to run it on a machine that has remoting enabled and v3 installed on the target as well. So I only have 2 v3 enabled machines in my lab, so I'm just going to query them multiple times. It comes back pretty fast as well. Let's see how fast.
Wow.
Yeah. So what this is doing here, it's creating a remote job on the target. So like the jobs example, it created the jobs locally, and That's what took so long, because when you create a job, it actually spins up a PowerShell process. So let's look at that. Go back to our basic job example. Look here at our results. And I have this filtered on my ISE process and for process create. It's off. See, every time a job starts, we get a new process spin up. And we're waiting on the last one, and then we're all done. All right, let's go ahead and stop that. Okay, so in our 4H parallel example, we won't see that. However, what happens if your machines, if you don't have V3 installed across your environment? Well, you can do the workaround, do the 4H parallel inside inline script. Now this is going to behave a whole lot different. So go ahead and run this. So again, these are the original 8 machines that we used in our previous example. Run this. You can run just an idea how quick it'll return. As we can already see, this is almost just as bad as Jobs. So let's see what's happening here. So let's go ahead and clear this out. I'm going to kill all my processes in the most unautomated way. Again, we're going to see our jobs be created, or our PowerShell process created as it starts each job. It's taking a little bit longer than it did last time. Hopefully it will complete any second.
That's pretty fast.
Yeah. So if I were to run my execution, measure execution time with this example, this definitely would have screwed up some results. Well, I hate to just stop this. I'm going to. All right. So what do we do again? Let's just run it again. That was a lot faster. And we can see 5 jobs spin up. I was talking to some of my colleagues before about this, and something about these workflow for each parallel. Like it only runs in five threads at one time. So I was looking around just on how do we deal with that. So if you look at let me see, if I just give me all the commands that help running workflow out. So let's give me a help on new -ps workflow option. Let's just give it the parameters. So you guys can see. So here we have a couple parameters. We can specify, you can't see that, can you? You can specify maximum running workflows, maximum sessions per remote host. I haven't played around with this to see if that's how we can get more threads, more PowerShell processes created, but to know which specifically one, but I'm pretty confident these are the ones we use. So, just so we can compare to see how much slower or faster this is to our other examples. And again, hopefully this won't take as long.
leaves those processes running those sessions?
They will go away eventually.
So it depends on your timeout.
Mm-hmm. They definitely go away eventually, but I missed one. But yeah, in the essence of time, I kill them for the demo. I really like to get all this on one screen for you guys. So remoting took an average of just over 1 second. Jobs took an average of just under 3 seconds and a maximum of 3.5 seconds. Runspaces, they're pretty speedy at just under half a second. The 4H parallel, they were the slowest at 3.6 seconds. And you can see the maximum took 9, but the minimum took 1.3. Interesting. And let's go back here, and we run the 4H parallel against the 2012, sort of the 2012 machines or the V3 machines. See, that wasn't as fast as it was last time. Just put it on the same scoreboard. So if you have all V3 machines, 4H parallel might be your best bet. Runspaces, they'll work in any environment because they don't require remoting to be on. Remoting, I think itself, Go Command is the easiest one. That's the one I always go to first. PS Jobs doesn't require remoting to be on. All we need is PowerShell V2. It's slow, and if you want to do it, right, make it, prime time, something you're going to blog about, you need to, come up with the code to throttle that and then get the results back. Runspaces are fast, C#-like code. There's lots of examples out there using Runspaces. I'm sure Tomei talked about it earlier today. He's blogged about it. Bo Prox has blogged about it, even on Ed's blog. So there's plenty of examples out there if you want to use that. In the 4H parallel, it's fast if you have V3. If you don't have V3 in the remote target, it's slow and troublesome. So for my resources, you guys see that okay? You need to zoom in. I take that as a yes. So I blogged on that on my Git, or pretty much what we just talked about here on the different methods we can use and when we want to use them. I blog about this on the Hey Scripting Guy. Here's a link to Bo's blog, which I recommend you highly check it out. If you want, you can follow me on Twitter. If you have any questions or want any of this code from these examples, just send me an email and I can hook you up. So with that, we have plenty of time, so hope you guys have some questions. Sir?
So the workflow one, when you went only to the V3 boxes and you ran the gateway event just in the 4H parallel, I'm suspecting that because that's a native workflow activity, gateway event, because that's one of the core commandlets, that's why it was so fast. Have you run a test using a command that you know is not a native workflow activity, thus it ultimately runs as an inline script on the remote side? Because you keep it's going back and forth between local versus remote code execution, but I suspect that was the only reason that was so fast, is because there was no PowerShell host that, or Runspace that hadn't started on the other side. Have you tested it by chance the other way?
No, I haven't. I always use it for the Get One Event example.
Definitely was a good advertisement though for the workflow activities, because that was fast.
Yeah.
Was the 4H parallel, was that serialized objects or was that?
It is serialized objects. I can so let's look at that. 4H parallel. It'll work out pretty well. Yeah, or put the code that to get down to those nested objects, put it inside
So
your
you
script
do it on
file.
the other side and then send it back to what you're doing.
I don't have this off the top of my head, but do you know if there's a way to configure the serialization depth for remoting, or is it always
I believe-
defaulting to like roughly 2 or something?
Yeah, I believe there is not. You know, one of the things I did run across was if you use export CLI XML, and you can specify the depth then. But then, you know, to use that method, you have to write the disk. That would just, you know, it's introducing another bottleneck. But no, yeah, to answer your question, I believe the answer is no. You can't do that for remote.
Let's do that.
Can you convert to JSON and specify the depth and send the JSON string back?
That'd be another option. Well, if that's all you guys got, you guys are on 15 minutes early. So that went a lot faster than last time I presented this.
Yeah, they were running fast today. Example.
Yeah. Yeah. But I think I've covered everything I wanted to cover. All right, guys, that's all you got. Be happy to see you around. Feel free to come up and talk to me. I can talk PowerShell all day long. And hope you have a good rest of the summit.